Hello, friends. All right, so this is probably my favorite lesson in probability of all levels, Algebra 2 up through like AP, Prob and Stats, conditional probability, because this is really the exciting part of probability and the more traditional, like real life use of probability, because usually conditions have to be met. So what I also like about this lesson is there's this really hairy, nasty formula in your probability and algebra books about how to calculate conditional probability. And I find that if you just think of it like a human would, it's so much easier to calculate. So I'm not, making a dig at the calculation, the formula, because there's probably a time in your college life where you're going to have to use that formula because there's no context to the problems. But the conditional probabilities, if you just stop and think, they become really, really nice and easy. So first thing we have to get around is there's a little bit of weird notation. So this notation right here, we know P stands for probability, and then the event that occurs is in the parentheses. So when it says B and then a vertical slash A, it means this. It means that event B occurs, and then given that A already occurred. So you might be thinking to yourself, like, why would that be a thing? It's very useful in real life probability calculations. So what is the probability that a Democrat will take the Senate seat given that you're looking at Illinois, something like that. So you want to restrict your probability to not the entire population of the sample space, the entire outcome, but just a portion of it. So this is a lame example, but bear with me. So what I would do is if you have a highlighter, marker, Crayola marker, crayon, anything, really anything, grab it. I'm going to use my highlighter. And what I'd like you to do in the problem, because there's a lot of reading and writing in probability, is highlight the given part. So Naomi's spinning this spinner over here. What's the probability that she lands on 7? And the part I want you to highlight is given that Naomi has spun a number greater than 5. Now, I'll go one further than that. I'm going to actually highlight on the spinner numbers that are greater than 5. So numbers that are greater than 5 would be right here. Oop. Yeah, that's good. So what we just highlighted is our denominator. So all this stuff here, this is going to be our denominator. And remember, the denominator is the total number of possible outcomes. So what conditional probability is saying is that I know the spinner will land on 6, 7, or 8. So the possible number of outcomes that we can have is a 3. It's either this, this, or this. Now out of those 3, what is the probability that it lands on a 7? Well, 7 is only one of those possible 3 outcomes. Ladies and gentlemen, you just found your probability. So the calculation is the same. It's favorable over possible outcomes. The only difference is the number of possible outcomes has been limited. It's not the entire spinner. It's given that the number is greater than 5. So we know it's going to land on a 6, 7, or 8. I don't know how you know it. You just do. All right, so we have that 6-sided number cube is back. And if I look at my sample space, I know it can be a 1, a 2, a 3, a 4, a 5, or a 6. So 6 possible outcomes, in theory, but let's get that highlighter working because we have conditions on each one of these probabilities. So I don't have to keep getting it out, and I've already bolded and underlined it for you, so that's kind of nice. But I'm going to go ahead and highlight this. Okay, so here's what I know. I need to get my face out of the way again. For this first question, it says a 4 is rolled given that the roll is even. So if you know that you're going to roll an even number, that means your denominator only has 3 possible outcomes, total outcomes. Let's look at this next example, though, before I get to the numerators and all these. The probability that you're going to roll something less than 6. So a 1, a 2, a 3, a 4, a 5. So that's 5 different possible outcomes. And then this third example has the given that you're going to roll a 3 or a 4. So somehow they know you're going to roll one of these 2 possible outcomes. Okay, so see what we did there is the denominator in each of our probabilities was changing. That's the big key difference here for regular probability versus conditional probability. So the probability that a 4 is rolled, well, y'all, there is only one 4 there. So 1. Now, I should have gone back here. Remember, the given part of this was that you were going to roll an even. I should have done this all in one step. My bad. So 1 out of these 3 is the winner. All right, so now the other one, remember we were going to, given that we were rolling something less than 6, so one of these 5. So out of those 5, the probability that a 2 is rolled, well, y'all, there's just 1 2 there. Okay. And then in this third example, the probability that you're going to roll an even number, given that you're rolling one of these, oops, I didn't erase far enough, given that you're going to roll one of these 2. So out of those 2, this is the only even number. Now, something you might notice is that each numerator there was a 1. It's not always going to happen. So don't think it's as simple as putting a 1 and then dividing it by how many you were given. It'd be nice if it was that simple, but it's not. I don't need to reduce any of those fractions, so we're moving on. Okay, so this is what we call a contingency table, and it's nice. The only thing I wish it had was a total row and a total column, but whatever, we'll deal with it. So we have people who play lacrosse, separated by class. So I don't think I've ever seen a lacrosse game, but freshman, sophomore, junior, and senior. Here we go. So find the probability, and I need my highlighter here, that a student plays lacrosse, and then here's the highlighted part, given that the student is a junior. So what that means is you're only looking at juniors. So that's why I didn't bother to go total everything. The only thing I'm going to need to total would be my juniors. So how many juniors do I have here? 544, I believe, if I add that. So that, my friends, is my denominator. So out of the 544 juniors, whoops, and remember, you're only able to look at the juniors here because of the given. Oh my gosh. Phone's going off. Okay, out of those juniors, they want to know probability that a student plays lacrosse. So does play lacrosse would be these 34. Now that, of course, reduces because they're both even. So I'm going to cheat and use my calculator. That's not my calculator. Oh, for Pete's sake, I closed my calculator. 17 out of, I don't even want to guess. Oops, math error. 1/16, of course. So that's the probability that a student plays lacrosse given that the student is a junior. So if you were only allowed to look at the data from the junior class, that's the probability. That's what it asks us to do on that question. All right, similar question, totally different concept though. Still have a contingency table. I'm going to get my highlighter out because I do see that given business again. So we want to know the probability that a person can attend the wedding given that the person is from the bride's family. So we are only allowed to look at data from the bride's family. So you're only allowed to look right here. So don't bother looking at the rest of the chart. Only look right there. So first of all, I need a total. How many total people from the bride's family were responding here? 136. If I added that right. So my denominator is 136. And the probability that they're looking for is that a person can attend the wedding. So can attend is 104. I know you guys are too young to think about this, but this is like a really important statistic. You know, when you compare, like, oh, how many of your people said yes to the wedding? It means a lot to some people. All right, that fraction reduces to 13/17. Again, percentages might make more sense. That's like a 76%, thing. And I think the groom's family's going to win out on that one. But you'd have to do the math to know for sure. All right. So that is another example of conditional probability. Yeah, for sure the groom had a higher bride. Okay, baseball. So we have our baseball team separated into classes, junior versus senior. And they want to know the probability that a student plays baseball. And then there's that word given again. Given that the student is a senior. So you are only allowed to look at senior data. That's it, nothing else. So the first thing we need, and it would have been over here, the total column would have been over there, but we're going to total these up. And I should be able to do this 340. So our denominator is 340. Oh, I guess it's your whole senior class, huh? And then the probability that a student plays baseball within the senior class is these 34 baseball players, which reduces to a 1/10. So pretty small percentage, but that makes sense. And this is made up data, I'm sure. I didn't make it up, but someone did. But you know, if you think about that logically, like, yeah, I'm pretty sure your baseball team couldn't have 300 people on it. So the fact that you have a pretty small percentage of your senior class playing baseball, that makes sense. Although I'm going to be honest, this looks like a really giant baseball team. Maybe they have like a separate JV and varsity or something. I don't know. Seems like too many. Like I said, it's made up data, so who cares? All right, and then this last one here. Again, there's no totals, so that's kind of annoying. But what we found is that we can calculate the totals pretty easily by just adding things together. Unfortunately, I think I have to bust out the calculator again on this one. So highlight, I'm going to get the highlighter out and I'm going to highlight each of the given pieces here. So given that the shopper is at Jacob's Gas, given that the shopper is at Pet Town, and given that the shopper is paying cash. All right, so we're going to do these one at a time. Given that the shopper is at Jacob's Gas. So we're only allowed to look right here at Jacob's Gas. That's it. I don't have a total. That stinks. So first thing I need to do is figure out the total here, which, sorry guys, I'm not going to try to add that. 304 plus 456 plus 380. So that's 1140. So my denominator here, oops, I'll put it over here, is 1140. Now, in that data, they want to know that the person, what's the probability that a person is using a credit card. So credit card, meaning just that 456. And again, I'm not going to reduce that. Oh, that's not too bad. 2/5 comes out to. All right. I wrote the wrong way. So 40% chance that if you're a shopper from Jacob's Gas that you used a credit card. All right, cool beans. All right, so what if you are, I get to erase all my highlighting. If you were drawn all over your chart, you might want to use a different color Crayola marker or something. A shopper uses a debit card given that the shopper is at Pet Town. So I'm only, oh, that's not a highlighter. Oh, whatever. I'm only allowed to look at data from Pet Town, and I'm going to need a total. Again, I should be able to add that because I'm a math teacher, but I think we all know better than that. Sometimes I'm brave and I try, but this is not one of those days. All right, so I know my denominator for this question is 147. Now let's talk about the probability component. The winners would be someone who uses a debit card at Pet Town. So debit card would be that 28. And again, I need to reduce that. I don't think that does reduce. Oh, it does. See, this is why I don't make assumptions. 4 out of 21. That says 21. All right, and then a final one here, which I get the luxury of erasing everything I just did. You might not have that luxury, so use a third color. All right. They want a shopper is at TJ's given that the shopper is paying cash. So this time I'm only allowed to look at data from people who are paying cash. That's supposed to be a straight line. There we go. So if I was to total all of this together, yep, not doing that in my head either. 304 plus 140 plus 102 plus 49. I mean, if I had to, I could, but why? So my denominator for this problem is a 595 for now. Out of those 595 people who pay cash, what's the probability that the person is shopping at TJ's? These 102 people. I'm not even going to guess if it reduces because I've been wrong like every time today. And it does. All right, 6 out of 35. Nice. All right. So that, my friends, is how you can calculate what's called conditional probability. I like when they're in a contingency table because it's so easy to like focus on the data you're supposed to focus on. Now, obviously, if it's on a piece of paper, I always suggest circling, somehow shadowing it in, highlighting it. And these show up quite a bit on your SAT test. So you're welcome to draw all over your SAT test. If you were doing these practice problems on Delta Math, however, you can't draw on your computer screen unless you have a touch screen. So you have to just kind of like visually focus on the part of the chart you're supposed to look at, or like highlight the words, but in your brain. So what I'm saying is these really become an issue of reading. How carefully are you reading the problem? And for some of us, that is the challenge. You know, we can calculate the probability just fine, but reading the paragraph becomes a little dicey. So I want you to really stop and focus and think about what are your options. You know, if you're working on a computer, use one of those read aloud text to speak applications on your Chrome browser. I think that's great. I think if you're working on paper and pencil, like the SAT test, highlight. And I know you can't physically highlight on the SAT test, but you can highlight with a pencil, even if that just means like underlining and bolding or crossing off other stuff, whatever it happens to be. All right, we are going to, speaking of SAT, sometime in this week, we're going to go over some sample SAT questions that are just like this topic. And you'll see how frequently they show up. It's actually a huge part of your SAT test. So hopefully this will stick with your brain for the next time you take your SAT. All right, good luck, everybody.